Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to see an important theorem, multiplication by powers of t from Laplace transform. So let's get going. So the theorem statement says that if L of f of t equal to f of s, then L of t power n f of t equal to minus 1 power n into d power n by ds power n into f of s for n equal to 1, 2, 3 and so on. Right? Proof. Let L of f of t equal to f of s. Since we know that L of f of t equal to integral 0 to infinity e power minus st into f of t dt, right, which is f of s, or simply f of s equal to integral 0 to infinity e power minus st into f of t dt, right? Consider as equation number 1. Now differentiating 1 with respect to s on both sides. Again, d by ds of f of s equal to d by ds of integral, let it be 0 to infinity e power minus st f of t dt, right? Now by Leibniz rule of differentiation under integral rule, we can write the RHS part as, we'll take this d by ds inside the integral as dou by dou s. Okay. Now find partial derivative of e power minus st. We'll get integral 0 to infinity. So partial derivative of e power minus st is minus e power minus st into inner derivative, that is derivative of st is st with respect to s. Let me write one more step. Okay, into f of t dt, which gives us integral 0 to infinity minus e power minus st into derivative of, partial derivative of st with respect to x is t into dou by dou s, that is partial derivative of s with respect to s, okay, into f of t. See, you can skip these two steps, okay. This becomes integral 0 to infinity minus e power minus st into t into partial derivative of s with respect to s is 1 into f of t dt, which gives us integral 0 to infinity minus e power minus st into t into 1 is t into f of t dt, right? Now we can write this as minus integral 0 to infinity e power minus st into t into f of t dt, right? we can consider t into f of t as one function, and it looks like integral 0 to infinity e power minus st into some function of t into dt, which is L of f of t, that is t into f of t, right? Since we know the formula, L of f of t equal to integral 0 to infinity e power minus st f of t into dt, or we can write this as integral 0 to infinity e power minus st f of t into dt equal to L of f of t, right? See, just compare these two. E power minus st into t into f of t into dt. Just consider this as some function of t, say some g of t otherwise. Then you'll get L of g of t, that is t into f of t. Okay. We have minus here. We got d by ds of f of s equal to minus L of t into f of t, right? Or we can write this as L of t into f of t equal to minus d by ds into f of s, or we can write this as minus 1 power 1 into d power 1 by ds power 1 into f of s, right? Therefore, L of t into f of t equal to minus 1 power it's 1 into d power 1 by ds power 1 into f of s, right? Similarly, so for first derivative, that is for first t, okay, multiplication by power of t, that is t power 1, we got minus 1 power n d power 1 by ds power n into f of s. Similarly, then for L of t square power 2, we'll get minus 1 whole square into d square by ds square into f of s. In general, we'll get L of t power n f of t equal to minus 1 power n into d power n by ds power n into f of s. Therefore, L of t power n f of t equal to minus 1 power n into d power n by ds power n into f of s for n equal to 1, 2, 3 and so on, right? Just remember this formula. Let's see one example now. Let's find L of t cos t. Okay, let's make it simple. So firstly, we'll find L of cos t. So here we are going to apply L of cos bt formula, which is s by s square plus b square, right? Then for b equal to 1, we'll get L of cos t equal to s by s square plus 1 square, which is s by s square plus 1, which is our f of s. So here our f of s is s by s square plus 1, right? Now coming to the problem, L of t cos t. If L of f of t equal to f of s, then L of t power n f of t equal to minus 1 power n d power n by ds power n into f of s. So here we have power 1, right? So for n equal to 1, we have to apply this formula for n equal to 1. If we have L of t power n into f of t equal to minus 1 power n into d power n by ds power n into f of s, then for power 1, that is for n equal to 1, we'll get L of t f of t equal to minus 1 power 1 into d power 1 by ds power 1 into f of s, right? That means we'll get minus d by ds into f of s. So here the required formula is L of t into f of t equal to minus d by ds into f of s. So we are going to apply this formula. Okay. So this becomes equal to minus d by ds of f of s. Just substitute f of s here. We have f of s by s square plus 1. This becomes minus d by ds of f of s is s by s square plus 1. Now we need to find derivative of s by s square plus 1 with respect to s. So now I am going to apply u by v formula. That is u by v dash. U dash v minus v dash u by v square. This becomes minus of derivative of s with respect to s is 1 into v, s square plus 1 minus derivative of s square plus 1 with respect to s is 2s plus 0, which is 2s into u, that is s by v square, s square plus 1 whole square. This gives us minus of 1 into s square plus 1 is s square plus 1 minus 2s into s is 2s square by s square plus 1 whole square, which is equal to minus s square minus into plus minus 1 minus into minus plus 2s square by s square plus 1 whole square, or just simplify this and later multiply the terms with minus. Okay, better. Let's not be in a hurry. Minus of s square minus 2s square is minus s square plus 1, right? This gives us minus into minus plus s square minus into plus minus 1 by s square plus 1 whole square. Therefore, L of t cos t equal to s square minus 1 by s square plus 1 whole square. This completes the problem. So we have seen an important theorem and an example problem in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.